Welcome to this video. In this video we will discuss in detail about the columns and column footings, and also about the wall footing. As you can see, these are the different drawings showing the detail of columns and the footing of the column, and also showing the detail of wall footings and the section of the wall. So we will discuss in detail about these in this video. So now I am going to zoom in so that we clearly uh, see about the different details given in this drawing. So I am going to zoom in. So we'll start from this top. So this is the detail of column footings. The concrete ratio that has been used for the footing of the column is 1:4, and it has a compressive strength of 3000 psi at the age of 28 days. So the different footing that has been provided for the different columns in this building is 3. This is the footing F1, and this is the footing 2, this is the footing 3. So the footing 1 is this one for the corner column. The footing detail for the corner column, the column which lie at this corner or at this corner or at this or at this, and the footing F2 showing the detail for the central column. This is the footing for the columns which lie at the center of the building, and the footing F3 shows the detail of the column of the footing for the column which is at the edge. So these are the three types of footings that has been used in this building. So the detail for the different footings is this. So this is the footing F1. The sizes for the footing F1 is 3 feet in A direction, means in this direction, and B is the 3 feet in this direction, in this vertical, means Y direction, and C is the thickness of the footing. So the thickness is 9 inch for footing F1, and the area of the steel for the footing 1 is this is in the x-axis direction. A is 1 area of steel in one direction, and this is the area of steel in the second direction, in the y direction. So for the footing F1, this is the A direction, this is the B direction, and the reinforcement in the x-axis direction, means at the A is 1, is to be provided with number 4 bar at the rate 6 inches center to center distance in this direction. We have to provide number 4 bars at the rate 6 inches center to center distance, and in the this y direction is it is designated as AS2. We have to provide the AS2 as number 4 bars at the rate 6 inches center to center distance. So the specification for the reinforcement we provided in this direction and in this direction is same for this footing F1. This is the putting and this is the column. Here this is the putting and this is the column at the center. This is the putting of F3 and this is the column at the edge. So for the putting F2, the dimensions are this. In A direction it is 4 feet and 6 inches in this direction. And in Y and at B, in Y direction it is 4 feet and 6 inches also in this direction. And the detail of the reinforcement for this putting F2 is the in the x-axis, that is AS1, we have to provide the reinforcement as number 4 bar at the rate 6 inches center to center distance, and in the y direction we have to provide the reinforcement as it is designated as AS2. We have to provide the reinforcement as number 4 bar at the rate 6 inches center to center distance. And this is the putting F3, and the detail for this putting is this. So in the x direction it has a dimension of 4 feet, and in the b direction means in the y direction it is 4 feet also, and it has a thickness of 12 inches. This putting F2 has a thickness of 15 inches, and this putting F3 thickness is 12 inches, means 1 feet. And the reinforcement detail for this putting is that in the AS1 should be provided as number 4 bar at the rate 6 inches center to center distance, and in the y direction means in this direction as it is designated as AS2, we have to provide the reinforcement as number 4 bar at the rate 6 inches center to center distance. So this was the detail about the puttings for of different puttings, that is F1, F2, F3. This was the detail. So now we proceed to the columns as we have discussed the reinforcement details for the puttings. Now we proceed to the different columns that has been provided in this building. So this is the column C1. So where is C1 lies? So now I will show you that where is the C1 column lies. So I'm zoom out and will show you the column C1 where it is lies in the building. So this is the ground floor. So here is the column C1 is this one, and this is the C1 column, and this is C1, this is C1, 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 C1. There are more columns as C1 in this building. So these are the C1 columns designated with C1. So we are now going toward the back to the detail about the column C1. So this is the drawing. So here it is the column C1. The dimensions for the column C1 is 9 inch by 9 inch. And the reinforcement detail for this column C1 is that we have to provide number 4 bars as the main reinforcement. These are the main reinforcement, and the shear reinforcement is these are called the ties. So we have to provide the ties with a specification that it should be of number 3 bars and provided at the rate 8 inches center to center distance. So this was the detail for the reinforcement detail for the column C1. So the another column is the C2. So it has a different detail from the C1. So here the reinforcement detail is that we have to provide the number 6 bars as a main reinforcement. These are the main reinforcement 6 bars, And the dimension of this column C2 is 9 inch in this direction and 12 inches in this direction. And also the ties that we have to provide should be of number 3 bar and should be provided at 6 inches as this distance of center to center about the ties. And this is the C2. So now we are going to another column. This is the another column C3. So this is a different profile, this column. So here we have to provide number 6 bar and 2 number 4 bars. The dimension of this column C3 is 12 inch in this direction and 24 inch means 2 feet in this direction. And the shear reinforcement means the tie should be provided of number 3 bars with 6 inches center to center distance. This is the column C4. So the dimension for the column C4 is 9 inch in this direction and 9 inch in this direction. And the main reinforcement is for number 6 bars. This is number 6 bars. And the shear reinforcement is the ties should be provided of number 3 bar at the rate 8 inches center to center distance. This is the another column which is designated with C5. So its dimensions is 9 inch in this direction and 18 inch in this direction, and the main reinforcement should be provided is number 6 bar, and the shear reinforcement should be provided as of number 3 bars at the rate 6 inches center to center distance. So these was the 5 types of different columns section that has been used in this building. So now we proceed to the another detail, others details. So this is the cross section of PB means plinth beam. The detail of plinth beam is this: the dimension of this beam is 9 inches in this direction in the x-axis and 9 inches in this direction means in y direction. The main reinforcement is provided in this beam is 2 number 4 bars here and 2 number 4 bars at the bottom, and the stirrups has been provided is of number 3 bars at the rate 8 inches center to center distance. So this is the detail about the cross section of plinth beam. And this is the another section beam. So this is the cross section of concealed beam 1. This is the concealed beam. This is the thickness of this slab, and this is the additional thickness to is provided for the beam. So this is 3 inch above from the slab thickness, and the reinforcement detail for this concealed beam is 3 number 6 bars at the top and plus 3 number 6 bar at the bottom, and the stirrups has been provided of number 3 bars at the rate 8 inches center to center distance, and the width of this beam is 15 inch, and thickness is thickness of the slab plus 3 inches. And so we proceed to the another other details. So this is the column, typical detail of column. This is the column and this is the slab. The beam, this is the beam. The beam is 18 inch thickness means depth, and this is the reinforcement, main reinforcement in the beam, and this is the column. So the main reinforcement in beam is 2 number 6 bar at the bottom and 3 number 6 bar at the top. Here at the support, we have provided the uh, more reinforcement, because here the negative movement is more, so we have to counter the negative movement. Therefore, the more steel is being provided at this top level of the beam. And this is the column reinforcement. This is this ties, and this small vertical line shows the thinner line shows the main reinforcement of the column. So this was the detail of the column. So now we proceed to the sections, the section view of the column. This is the column at the corner, and this is the column at the edge, and this is the column at the center. Corner column putting details. This is the interior, means at the center of the building. This is the interior putting detail, and this is the edge putting detail. So here, this is the PCC for the putting. It is same in this, it is same in this. All at the corner putting, at the interior putting, and at the edge putting. This is the same. And this is the RCC. And these are the different steel in the this direction and perpendicular to the plane. AS1 and AS2, as we have discussed in this at the start of this video. And these are the ties of the column, and this is the ground level, and here it is the floor finish level, and this is the PB, the plinth beam. This is the column main reinforcement. This small this thinner line shows the column reinforcement in this column, and shows in this column these thinner lines. These are the ties. These are the ties in this column, in this column, in this column. And here, this is the bottom level of the putting. So we have to excavate the ground from this level. This is the ground level, and will come to here, as this distance should be specified by the geotechnical engineers, that how much we will go down so that we get the required bearing capacity of the soil. So it depends on the bearing capacity of the soil, and it is different at different locations depending on the type of soil. So normally it is minimum 5 feet we have to go down from the ground level to cast the putting, but it depends on the soil properties. This depth of the putting may differ from location to location, and this also depends on the building loads, that where we have to put the foundation, so that we have to resist the load coming from the buildings. And this is the floor finish level, FFL. This is the plane beam here in this column, and this is the plane beam in this column. And this is the thickness of the footing. This is the thickness of the footing, and here it is the thickness of the footing. This is the AS2 steel that has been provided. It is perpendicular to the plane of this, and this is the AS1, which is in this direction, in the x-axis direction provided. So now the video is going to more longer if we proceed to the next detail about the wall footing. So I will discuss it solely discuss in this video. So this is the typical cross section of wall footing. We have discussed about the columns till now, and now we are proceeding toward the wall footing. So this is the wall footing. There are different types of wall footing provided in this building, as we have discussed in the previous videos. So this is the wall footing 1 cross section, and this is the wall footing 2 cross section, this is the wall footing 3 cross section, this is the wall footing 4 cross section. So in the wall footing WF1 cross section, this is the width of the wall footing. This is 3 feet, and at the footing here we have to tell when we reach to the designated level by excavating the footing, by excavating from here this ground level, and we reach to this designated level, and it depends on the type of the soil, it may vary this distance. So for this building it is 4 feet and 6 inches. So for this wall, so this is the bottom of the excavated area. So here we have to provide the granular material as a pillar at this bottom of the excavated portion, and above this granular pillar material, it has a thickness of 8 inches. Above this pillar we have to provide the PCC, plain cement concrete, of 1:8 ratio, and it has a thickness of, normally the PCC has a thickness of 3 inches here, so here we have also provided the thickness is 3 inches, and then we have to provide this RCC as the footing, so it has a thickness of 1 feet, means 12 inches. This is the detail of the reinforcement, is number 3 bar that the 8 inches center to center. This is in the this direction, perpendicular to this plane, and in the horizontal direction, means in the S direction, we have to provide the reinforcement with the specification is number 4 bar at the rate 6 inches center to center distance. Above this RCC footing, we have to provide this brick masonry of, this is the in step. So this is at this level it has a thickness of width of 22.5 inches and thickness of 6 inches. In this step you have to provide the brick masonry is a width of 18 inches and thickness of 6 inches, and this we will proceed till this level, and this is the ground level, and here it has a width of 13.5 inches. This is at this level we have to provide the plinth beam, and this is the floor finish level. So this was detail about the cross section of footing F1. So now we proceed to the cross section of footing F2. This is the cross section of wall footing, of the interior wall footing. This is the edge wall footing, means at the corner wall footing. So the wall footing F2 cross section, this is the cross section for WF2 wall footing 2. So this is the granular material, this is the PCC, then RCC, this is the breakworks till this level, and here we have to provide the plinth beam, and this is the ground level, this is the floor finish level for this footing. The reinforcement detail for the RCC is number 3 bar at period 8 inches center to center in this direction, this, and in this direction we have to provide number 4 bar at period 6 inches center to center distance. So now we proceed to the another type of footing. This is WF3. So after excavation we have to provide the granular material as a pillar, then PCC, RCC, then the breakwork, and we will proceed till this level. We provide above this level we have to provide the plinth beam, and this is the floor finish level. And the reinforcement detail for this RCC footing is that in this direction, means the perpendicular to this plane, this reinforcement we have to provide as number 3 bars at the rate 8 inches center to center, and in this horizontal direction we have to provide the number 4 bar at the rate 8 inches center to center distance. So this was about the wall footing F3, and this is the wall footing F4. So the detail is about this footing as it has a width of 2 feet, means 24 inches. Here we have to provide the granular pillar, this is then the PCC, and then above the PCC we have to start the breakworks in steps. This is a step. Here is the width is 13.5 inches, here is 9 inches, and then we will here reach to the floor finish level. This is the ground level. So this was all about the details of the columns, footings of the columns, and wall footing. So thanks for watching, and please subscribe to this channel for more videos.